Hi class, today we're going to discuss estimating products, and before we do I want to do a quick review on rounding off numbers because that is a crucial element to estimating products correctly. So in our table to the right I've written above it if the number before the value, now this is the number before the value we are rounding to, is less than 5, then we simply add 0 to the number we are rounding to. If the number before the value we are rounding to is greater or equal to 5, then we want to add 1 to the number that we are rounding to. So let's do a couple of examples with this number 6,736,592. And I want to do one of each so that you have a clear idea on proper techniques to rounding. So first, let's say we want to round to the nearest 100,000ths. That is the 7 here, okay? If we want to round to the 7, the first thing we do is we look to the value immediately to the right, and we see the value is 3. Looking at our table above, we see that 3 is less than 5. So we're going to add 0 to the 7 and rewrite the number. So now we have 6,000,000 7 because we just add 0 to 7, and everything to the right just simply goes to 0. So we have 700,000 even. Okay? Now if we want to look at another example where we are going to add 1, let's see what would make a good value. How about we round to the hundredths place? Okay, so we're going to round to the hundredths place. So we want to look at the value to the right of the 5, which is a 9. From our table above, we see that the number before is greater or equal to 5 because it's 9. So 9 is, if I write it in here, 9 is greater or equal to 5. We're going to add 1 to the column that we are rounding to, which is the hundredths column. So we rewrite our number, 6,736,000, 36,000. We add 1 to the 5, so we get 6, and everything to the right goes to 0. So if we've rounded off to the hundredths place, we have 6,736,600. Now with this in place, we can take a look at our problems over here, and we'll start with number 1. And I'll rewrite it over here. It is 42 multiplied by 2. Okay? And the instructions say, round the larger number to the greatest place, then estimate the product. Well, the greatest place in this problem is the tens column. That's the 4. So we want to look at the number to the right and check our table up here. Is 2 less than or greater than 5? Well, it's less than 5. So we add 0 to the 4, which means we rewrite this problem as 4, we added 0 to it, and everything to the right goes to 0, multiplied by 2. Now, a neat trick about multiplying powers of 10, 40 is a power of 10 because we can say 40 is equal to 4 times 10. All we have to do is multiply the two non-zero values and add the number of zeros. Okay, so here we only have 1 0. So we can say 2 times 4 is 8, and we simply add 1 0. So 2 times 42 estimated is about 80. Okay? Really, 2 times 42 is equal to 84. But 80, since we're estimating, is really close to 84. Let's take a look at number 3. Okay, let me just put number 1 here. We'll say number 3. This one is 59 multiplied by 2. Okay, so we look at our table above. It's again, we're rounding to the larger number, round the larger number to the greatest place. So that's 59 is the larger number, and the greatest place again is the tens value. So we look at the number to the right of the 5, and it's 9. Again, we have, I've already written it in here, 9 is greater than 5, so we're going to add 1. So we can rewrite this problem over here by adding 1 to 5. We get 6, and everything to the right goes to 0, and that's multiplied by 2. Again, 60 is a multiple of 10, 6 times 10, right? Just like the 4 times 10. So we only need to multiply the two non-zero numbers and add 1 0 in this case because it's a multiple of 10. And that would give us 12. 2 times 6 is 12. And we simply add the 1 0. Okay? So a good estimate of 2 times 59 is 120. Now if we want to see what the real value is, we would say 2 times 9 is 18. Carry 1. 2 times 5 is 10, plus 1 is 11. So you can see that 120 is really close to 118. Again, this is estimation, so we're not looking for an exact answer. Now, we want to try one that has a little larger number here. Number 5. We have 565. Let me just write number 5. 565 is our larger number, and that is multiplied by 4. So times 4. Okay, and we're rounding to the greatest place. In this case, looking at our tables, you really want to memorize this table, the ones, tens, hundreds, thousands, and so on, all the way up to millions. Our largest place is the hundreds. So we look at the number to the right. It's 6. Come back up here to our table, and I want to erase this 9. Okay. 6 is greater than or equal to 5. So we're going to add 1. Okay. And we can rewrite this problem now by adding 1 to our largest digit here. We've got 6, and everything to the right goes to 0. Okay. Just put an arrow here. Multiplied by 4. Now again, 600 is a product of 100 here, so we can say 6 times 10, right? No, times 100. So you see that we have two zeros. We only need to multiply the two non-zero values and add the 2 zeros to it. So 6 and 4, when you multiply those, you get 24. You add the 2 zeros to it, and our value is 2400. And if we check this against what the original value was, we have 4 times 5 is 20, carry 2. 4 times 6 is 24, plus 2 is 26. Carry 2. And 4 times 5 is 20 plus 2. So we get 2260. Okay? And you can see that we rounded up so to 600 here, so of course this value is going to be larger than the original one. Okay, in comparison. But 2400 is a good estimate when we're just looking at this difficult number to multiply. And I want to give you an example on why this, or how, an example on how this could come in fairly easy here. Let's see. Okay. Let's say someone asked you to look down at this parking lot and give you need to give them an idea of how many cars are in this parking lot. And you can see that there are some spaces that are empty in this parking lot. But it would be a real difficult task to count all of these cars. Okay, but we can see that more than half of the parking lot is full. Okay, so we could round up. And if we just round up, we know that we're going to be looking for a value that's going to have all zeros behind it. So what we can do is count one row across, just one, not both cars, but just one single row, like say down here, okay, this row. And because we don't see the end of the picture, we're going to just make a guess that somewhere not far off the picture there is an aisle that goes up so that people can park. And if you count these cars, I think there's somewhere around 35 cars in a row that we can see. But let's round it up to 50. Let's say there's 50 cars to a row. Okay? So we say 50. How many rows are there? Well, we count our groups of 2. So we've got 2, 4, 6, 8. So we have, I'll just put a comma here, we have 8 plus, and now our groups of 1, there's 1 down at the bottom here, and 1 at the very top, plus 2. So there are 10 rows. Now it becomes real easy to multiply. We simply have 10 times 50. Okay? The nice thing is, because these are multiples of 10, all we need to do is to multiply the non-zero numbers and add the number of zeros that we see. So we get 5. 1 times 5 is 5, and there are 2 zeros. So we could tell somebody that there is approximately, and this is the symbol for approximately, it's a squiggly equal sign. There are approximately 500 cars in this parking lot with just one other person. There might be 2 people in the car. But some people load up the whole car, maybe 5 people in a car or a minivan. So if you have, at the lower end, you have 2 people, but at on the higher end, there might be 5 people in the car. Okay? We can pick a value somewhere in between. We could say, I don't know, let's say on average there are 3 people then in the car. Okay? Now you just take the 500 cars, multiply it by 3, and again, all you have to multiply are the non-zero numbers. Okay? 3 times 5 is 15, and add the number of zeros that you see. There's 2 of them. So we have 1,500. So this might be one small parking lot at Disneyland, and you could say that approximately this parking lot, 1,500 people came in this parking lot. So hopefully that helps you with rounding numbers and estimating products, and I will talk to you again soon.